What is equation of simple harmonic progressive wave? Anybody knows? Equation of simple harmonic progressive wave. It is y equals to a sine 2 pi t by t minus x upon lambda, which can be thought as a sine omega t plus or minus a. So one sum you can expect they will give equation and they will ask you either velocity, frequency, time period, amplitude. So x ka coefficient is always k, t ka coefficient is always omega. By comparing, I can get velocity omega by k, which I told you last class. So equation of simple harmonic progressive wave a sine omega t plus or minus kx. Plus means moving on negative x-axis and minus means moving on positive x-axis. Right this? Okay?
Yes, sir.
Formation of beat frequency. See, beat means melodious voice. So if single source is emitting sound like this, is it beat?
No, sir.
But ऐसा है like ambulance, तो beat हो जाता है. So for beat, we require two sound wave to superimpose between each other. If their amplitudes are widely at wide difference, that means one is 20, another is suppose 19 only, कुछ difference नहीं. और बहुत difference हो गया तो suppose ये 1 है, so when they add it will become 21, when it subtracts it becomes 19, almost same लगेगा ना हम लोग को. मतलब इसका 21 जब ऐड हुआ साउंड ऐसा आवाज आया, अकेला 20 का आवाज आया 1 का साथ में मिला, समझ में नहीं आ रहे कम है क्या जा रहे. बट इफ एम्पलीट्यूड इज 20 and 20, when it add it becomes 40, when it subtracts it becomes 0. तो जब ये ऐड होएगा तो आवाज बहुत जोर का आएगा, सब्ट्रैक्ट, the amplitude must be same so that we can hear maximum sound and minimum sound clearly. This is called as waxing, and minimum sound is called vanning. Vanish हो गया, vanning. So amplitude of two sound wave must be equal, then it will be best formation. अभी देखते हैं frequency क्या चाहिए. If frequency is same, frequency is same, frequency is same. So if they move in phase, then crest crest truff truff crest crest truff truff will mean together. तो इसका आवाज आएगा maximum sound. Always only maximum, maximum, maximum. That means I will hear no minimum sound. For example, इसका अकेले का आवाज आ रहा है, इसका इसका अकेले का साथ में आता बट नॉट एनी मिनिमम इन बिटवीन, सो ये नहीं चलेगा। अब ये दोनों ऑपोजिट फेज में है। तो एक का आवाज दूसरे का भी साथ में आता मतलब कैंसिल हो गया, तो ये भी नहीं चलेगा। So there must be difference in frequency. Same frequency, it won't give you appropriate result. You can't identify. Abhi is 30 waves and this is one wave. How many times they will interfere? At least 30 times. Hello? How many times they will interfere? 30 times.
Yes,
Yes.
sir.
So if 15 times I hear maximum and 15 times minimum, my eardrums have some problem of persistence. उसको एक सेकेंड में 10 बार कोई चीज आए तो ही आइडेंटिफाई कर सकता है। आई थिंक यू नो दिस, persistence of sound होता है ना एक, so that's why for echo sound goes and comes back if it is minimum 1 by 10 second, इससे कम नहीं चलेगा, then you can identify the reflected sound which is called echo, correct no?
Yes.
Yes, sir.
तो अगर 15 टाइम्स एक सेकेंड में इंटरफियर हुआ तो इट इज लाइक आई एम स्टैंडिंग अंडर द लैम्प पोस्ट एंड नाइट टाइम पे वो कीड़े लोग घूमते रहे, आवाज आता है, समझ में नहीं आता मैक्सिमम है क्या मैक्सिमम मिनिमम। So sound wave should have same amplitude, true. Different frequency also true. But difference should not be greater than 10. Otherwise, we cannot identify the formation of maximum or minimum. So sometimes they will give option in theory for formation of beat frequency, which is correct. So write down for formation of beat to waves must be of same amplitude but slightly different frequency. Slightly different frequencies. So N1 difference with N2 should be less than equal to 10. The maximum sound is called as waxing and minimum sound is called as banning. Alternate formation of waxing and banning is called as formation of beats. Number of beats heard per second is called as beat frequency. Copy this much.
Done, sir.
Time interval between successive waxing or successive waning is called as time period of. Are you remembering resultant displacement during beat formation? Resultant displacement during beat, I'm writing formula. Y equals to 2a cos of 2 pi n1 minus n2 into t upon 2 sine of n1 plus n2, 2 pi n1 plus n2 into divided by 2 upon. So this is formula for formation of beat. So when two sound waves having amplitude same, slightly different frequencies arrive at a point simultaneously, alternately maximum and minimum is formed. Maximum is called waxing, minimum is called waning, and this formation is called beat frequency. तो जब भी आप डेरिवेशन करोगे तो आपको रिजल्टेंट ऐसा मिलेगा 2a cos 2 pi n1 minus nt and sine का 2 pi n1 plus n2 into t upon 2. I am writing this because sometimes they can ask what will be the frequency of the resultant. So frequency is this of पूरे wave का average और ये beat frequency है n1 minus n2. Sometimes they will give you this equation and they will ask something. Hello, shall I explain this derivation or you know this? हेलो,
Sir, can you explain?
पहले लिख लो फिर मैं रफली एक्सप्लेन कर देता हूँ और फिर खाली आपको इतना ही लिखना, इतना लिखो, but derivation you will not write, I am explaining it. Copy this को.
Done, sir.
No, see फटाफट the derivation how we got this frequency case under. So y1 is a sine 2 pi n1t, y2 is a sine 2 pi n2t. So resultant is y1 plus y2. That will become a sine 2 pi n1t plus a sine 2 pi n2t. So this is a common sine t plus sine t. So this is nothing but a 2 times sine c plus e upon 2 cos e minus e upon 2. That is y equals to 2a cos of 2 pi n1 minus n2 into 2 sine of 2 pi n1 plus n2 into here. So resultant wave will have frequency, average frequency, amplitude will be this. Now follow that part.
Yes.
What is formula for beat frequency? Formula for beat frequency, any idea? Beat frequency is difference in frequency, either this or n2 minus n1, larger minus smaller, uses of beat frequency. First use. It is used to find unknown frequency of tuning fork. ये part बहुत important. Unknown frequency of tuning fork. How I am explaining it. It is used to find unknown frequency of tuning fork. Let n1, n2 be known and unknown frequencies of tuning fork, producing x beats per second when sounded together. Therefore, n1 minus n2 will be x beat, or n2 minus n1 will be x. Correct now? Because I don't know who is larger. So either n1 minus n2 will give me x beat, or n2 minus n1 will give me x beats per second. Everybody is followed till this point.
Yes.
इतना कॉपी करो. Don't read any textbook nowadays. Practice down. If you get doubt, ask me. I will clear your concept rather than you investing your valuable time. Yeah, shall I clear it to explain further?
Yes, sir.
अभी देखो n1 माइनस n2x और n2 माइनस n1x, लेकिन आपको चेक करना पड़ेगा कौन सा करेक्ट है. तो उसके लिए हम लोग दो मेथड यूज करते हैं, लोडिंग एंड फाइलिंग. सो इमेजिन लार्जर इज करेक्ट. एक इमेजिन बोल रहा हूँ, लार्जर इज करेक्ट. इफ नोन is 100 with unknown, it is giving 5 and unknown is larger, so 105 होगा ना फिर. ओके. हेलो.
Yes, sir.
unknown you are known you are not changing, unknown तो ढूंढने के अपने को. so I am predicting if it is larger than 105, it is smaller than it should be 95. This is known, this is unknown, giving 5 8, so it can be larger, it can be smaller. Suppose it is larger and you load it, then it will become 104, 103, 102. It will keep on decreasing. Hello?
Yes.
So this beat frequency is also decreasing, na? 3, 2, 1 and so on. If I load unknown and it is smaller, so ये 94, 93, 92, 91 ऐसा करके मुझे आंसर 5, 6, 7, 8, 9 ऐसा देगा ना. ये लार्ज और ये स्मॉल. करेक्ट. हेलो.
Yes, sir.
सो एक लाइन मैंने मेरा दिमाग पे रखा है. When prongs of unknown tuning fork, when prongs of unknown tuning fork are loaded, then frequency will decrease. This is for sure. Frequency will decrease. If beat frequency also decreases, lower arrow means decreases, then unknown is larger one. Larger one matlab n2 minus n1 is beat, or unknown will be known plus beat. Unknown is larger, that is n2 will be n1 plus x, or else n2 will be n1 minus. So frequency decreases, bit frequency also decreasing, unknown was larger, or else unknown was smaller. Okay, hello?
Yes, sir.
Yeah. First be satisfied. Have you followed on what we said?
Yes, sir.
अभी इसको मैं फाइल करता हूँ, इतना लिखो, उसका नीचे इतना लिखो, बिकॉज मुझे लग रहा है एक ऐसा छोटा सा काम आ सकता है. चले क्लियर ना?
Yes, sir.
अभी फाइलिंग करो. 105 is unknown, known is 100, giving 5 bit. So here we have assumed larger unknown. If unknown is smaller, known के साथ 5 bit, so it should be 95. Now when I file, then frequency will increase 106, 107, 108, and so on. This will become 6, 7, 8, so on. So frequency is increasing, beat frequency is also increasing, unknown was larger in that case. If I file unknown when it is smaller, तो उसका तो frequency बढ़ेगा, but corresponding beat frequency is reducing. This is increasing and this is decreasing. So whenever reverse happens, one increases, other decreases, then smaller is cut. Same, both increases, both decreases, then larger is cut. So when prongs of unknown tuning fork are filed, when prongs of unknown tuning fork are filed, then frequency increases. If bit frequency also increases, then unknown frequency n2 is n1 plus x, or else n2 equal to n1 minus. Just write this, then I'm giving you example with number.
Done, sir.
One with example, we'll see what it is. Now suppose A and B are tuning fork. This is 300, giving 5 bits per second with B. So what are chances of frequencies of B? It can be 300 plus 5, that means 305, or 300 minus 5, that means 295. These are two chances.
Yes, sir.
Okay. Now, if it is given like this, after loading, beat frequency increases to 6. After loading, beat frequency कम होएगा तो larger ज्यादा है ना. Here, after loading, frequency will decrease. If beat frequency also decreases, then larger is correct. ये अपना आंसर रहता है. But beat frequency has increased, therefore smaller is correct. Smaller is correct. Smaller is correct means 295 is correct. Okay, followed method. Hello,
Yes.
please write this example. Done, na?
Yes, sir.
Yes, sir. Octave means frequency is double. So if they say frequency of last is octave of first, that means last is double of first. So octave means frequency is double. This we have to remember. Doppler effect. Doppler. See, sometimes train blowing whistle from far distance, when it approaches, we don't hear it that louder. As soon as it comes closer, हम लोग अपने कान में उंगली रख के बाजू हो जाते हैं, आवाज जोर का आता है. That means that person or the driver is not blowing the whistle with larger amplitude. We are collecting more wave so that we feel that we are hearing louder. So same way, if somebody is shouting and I'm not able to hear, तो जनरली हम लोग क्या करते हैं, कान के ऊपर एक हाथ रख देते हैं ना, ऐसा कॉन्केव शेप करके. अभी कॉन्केव शेप किया मतलब क्या, वो सामने वाला जोर जोर चिल्लाया. Only that sound is incident on my palm, getting reflected back into my ear, so I feel that I can hear it louder. That phenomenon is called Doppler effect. That means whenever there is relative motion between whenever there is relative motion between source and listener, then apparent मतलब जो हम लोग को सुनाई पड़ता है that one, then apparent pitch of sound is different than actual pitch of sound. Is different than actual pitch of sound. It goes on increasing when distance goes on decreasing and vice versa. This effect is called as Doppler effect. That means changing of frequency just by relative motion between source and listener is called as Doppler effect. Right definition? Then I'm giving formula. Source approaches what will happen or listener approaches what will happen. Hello? हाँ सर. हाँ देवेंद्र वर्मा सर बोलते हैं. देवेंद्र वर्मा सर. आज तो मध्ये राहुल डिस्कनेक्ट झालेला आहे त्यामुळे फोन केला. नाही नाही आता आहे तो. हां.
Done, sir.
When source moves, always adjust denominator. So apparent frequency when source approaches, frequency will increase or decrease when source approaches. Frequency will definitely increase. So formula is apparent frequency is actual frequency. ये V और V ऐसा याद रखना ratio. Then approaching adjust denominator, subtract it with velocity of observer. So frequency increases, denominator decreases. Here N is actual frequency, N1 is apparent frequency, V is speed of sound, and U is speed of source. Same way when source moves away, then apparent frequency is N. ये V upon V format याद रखो. Adjust denominator. Frequency come, so denominator charge. So these are two formulas for source coming closer or moving away. Please write down. ठीक है।
Yes, sir.
एक और फॉर्मूला करा देता हूँ। लिसनर मूविंग, देन वी कैन स्टॉप। लिसनर मूविंग अवे, listener moving. Adjust numerator, this you have to remember. Now listener coming closer, frequency will increase. N1 is N V upon V. Adjust numerator, so numerator should increase. Listener moving away, so frequency will decrease. That means numerator will decrease.
Done, sir.
So today we'll stop here. Please revise all the formula and always be ready for test. Tomorrow's test, I think you know.